When a fire breaks out in a high-rise, the most immediate structural vulnerability is the elevator shaft. By its very design, an empty, multi-story concrete elevator core acts as a massive vertical wind tunnel. This phenomenon is known as the chimney effect. Because hot air is less dense than cold air, it rushes upward, creating a powerful draft. That draft pulls open flames and toxic smoke directly into the shaft, violently distributing a localized single-floor fire to every previously unaffected level above. The point of failure is often the hardware separating the floor from the shaft. Under extreme thermal stress, standard non-rated metal doors will rapidly heat, warp, and melt. Once the seams buckle, the fire breaches the shaft. That makes the elevator landing door your absolute single point of failure. It is the only physical defense preventing an isolated incident from escalating into a full building catastrophe. Countering that thermal pressure requires an active engineering solution, specifically designed to absorb and block those forces. That is exactly what the Witter 3201 Hydra lift landing door was built to do. To understand exactly how this barrier operates under pressure, we teamed up with the experts at OEL Engineering Service Provider, guided by engineer Alokes Biswas. We are going to tear down the mechanics of the Hydra door to see exactly how it survives conditions that would liquefy standard hardware. In everyday operation, the 3201 Hydra operates quietly in the background of lobbies. It opens, closes, and blends in. But looking beneath the surface aesthetic panels reveals a heavy-duty mechanical skeleton. The core of its stability relies on this internal sliding block mechanism. Unlike lighter-duty doors, the Hydra system utilizes a minimum of 2 reinforced sliding blocks for every single panel. These blocks are crucial. When exposed to intense heat, metal undergoes extreme thermal expansion, twisting and expanding outward. The dual block setup forces the panel to remain rigidly locked to its track, absorbing the structural deformation. By locking the panel mechanically to the rail, the door maintains a tight, unyielding seal against the shaft, even when battered by immense atmospheric pressure and heat. Of course, building planners cannot rely on theoretical mechanics to protect human lives. The door survival must be independently proven, which brings us to safety certification. Looking at this official TÜV SÜD certification document, you will see compliance with EN81-58. This designates the strictest, most rigorous European standard for fire resistance in lift landing doors. Securing this stamp means the physical hardware survived grueling, highly documented stress tests inside independent laboratories, like the UK-based Exova Warrington fire facilities. These documents function as legally binding guarantees. When a disaster occurs, the hardware will perform exactly to the millimeter of its engineered specifications. This split-screen diagram illustrates the highest rating the Hydra door achieves, EI120. In thermal physics, a fire presents 2 distinct threats, represented by the E and the I. The E stands for integrity. This confirms that for a full 120 minutes, the physical structure of the metal will not collapse, warp, or allow a single open flame to breach. The I stands for insulation. A door can physically block a flame while still conducting enough radiant heat to instantly ignite nearby objects. The insulation rating means the door actively blocks that thermal transfer, keeping the safe side cool enough to prevent secondary fires and protect escaping occupants. Achieving EI120 effectively turns the elevator entryway into an impenetrable 2-hour firewall, buying crucial time for full building evacuation and emergency responders. Historically, integrating heavy-duty, life-saving safety barriers meant forcing architects to accept bulky, industrial aesthetics in their high-end designs. The engineering of the Hydra series solves this by remaining highly adaptable. The system scales from standard 2-panel setups all the way to massive 6-panel configurations, available in both center and side opening formats to fit any dimensional requirement. The thermal blocking technology is so refined that the doors can even be constructed using elegant glass frame designs, all while retaining their full EN81-58 fire rating. Building planners are able to execute their aesthetic vision with zero compromise to the building's critical safety infrastructure. But the hardware only works if it is integrated correctly. As stated directly on the cover of the 3201 Hydra Instruction Handbook, maintaining the validity of the EN81-58 rating requires strict adherence to the manufacturer's blueprint. There can be absolutely no alteration or tampering with the original components. This is an integrated precision safety system. It demands exact professional installation, adjustment, and maintenance by trained engineers. For ultimate reliability and vertical transit, the industry's top developers rely strictly on certified, factory-tested solutions implemented by expert integrators. A special thanks to the technical team at OEL Engineering Service Provider for guiding us through the mechanics and ensuring these systems operate flawlessly. We interact with elevator doors every day, but when a crisis hits, that simple entryway immediately operates as a highly engineered shield, specifically designed to protect human life.